In this video, I'm going to show you how to use Statcrunch to calculate your test statistic for the goodness of fit test. And we already looked at this problem, and we already figured out the observed and expected values. So I want you to pull out that example and follow me. So here I'm in the Statcrunch, and I put in my categories already, and I also put my observed value and my expected value. Let's change our column headings to observed and expected. All right. So you still calculate it as I showed it in the example. And just a side note, remember one of our requirements was that the expected frequency was at least 5, or at least 20% of the expected frequencies would be at least 5. So we're good here. And the requirement is also only for the expected values, not the observed values. So the fact that the observed value is 2 is not a reason for a concern. Okay, so after we've done our observed and expected values, we're going to go to Stat, Goodness of Fit, chi-square test. And then you're going to select for your observed value. Observed. And for expected values, you're going to select expected. So we named those accordingly. Okay, and then don't worry about where to group by and display. Just leave it as is. Now, these residuals, standardized residuals, are not the ones that we were talking about. So don't actually, we cannot use them very much. So you have your observed values, the expected values. It's just a repeat of our table. But here you have your chi-square value, 51.01575 is what we got. And then your p-value, it's already calculated for you. So, and then go back to the problem and finish it up. That's how you use Statcrunch for it. Now, I want you to show one more trick. If your expected distribution is uniform, like in example 1, you don't have to calculate your expected values. The Statcrunch will calculate them for you. So you would go to goodness of fit chi-square test, and you would select your observed values still. You need to do that. But for the expected values, you would select all cells in equal proportion. So it will divide the sample among the categories in equal proportion. And then you hit compute, and here it calculated the expected values to be the same. Just like, I mean, this would not be useful for example number 2 because our proportions were not the same. But for example number 1 that we learned earlier, this would work.